Thank you. Thank you so much for that nice introduction. And I'd like to welcome you all for this session. And I'd like to thank the organizers for giving me the opportunity to kind of come and talk about this particular topic. And I'm glad to be here. And see, the objective is very simple and clear. Just want to take some of the basic stuff out. Okay, so that at the end we get a very good clarity on the kind of data that we are dealing with on a day-to-day basis, right? What is it we need to do? So as a country, our the innovative index, right? I think it has gone up a little bit. So any idea where we are as of today? It came in the newspaper today morning. Okay, so we are at the rank 60. Okay. So that clearly shows the kind of the importance that we are giving to the technology, right? The generations are really kind of showing interest towards kind of understanding the basics of the technology. Okay, still we have to improve upon. Switzerland, Netherlands, US, UK, they are the top players. Okay, so India as a country has to be visualized as the innovative things are coming out. Okay, we should not be just consumers of the product, the technology. Okay, and I think we are really doing well. And the evolution of the technology also is really kind of helping this current generation. Like you might have listened to the talks right today, and the subsequent sessions that will be delivered. It will be mostly around data, how to deal with the data. Right, everyone has their own platforms and tools. Okay. So whether it is Microsoft or Google or IBM or whoever it is, everyone is kind of coming out with a very nice tools, right? But it is always better to understand the basics of how that is approached. So we as a consumer or a developer or as a business person, I kind of need to know how to approach this tool. Okay, that is very, very important. And like the technology evolution is in such a way that we are started depending on the systems, right? Human to human interaction, yes, it is there, right? So that is why we are here. We are kind of interacting and discussing. Probably tomorrow I may not be here, or the speakers may not be here. We'll have some systems coming here and delivering the sessions for you, right? So that is where we are evolving. Okay, one way it is good, I would say. Last time when I had met Rajesh, the organizer, probably a couple of months back. Today I walked in and he asked me, "You are from which company?" Okay, so the difference basically, I was not having the bird that time, and probably, like my look and feel has changed a bit. He couldn't recognize. Probably if I depend on the system, it could probably say that, okay, Rajesh, welcome to the session, right? So I'm just saying the way we are depending on the system to kind of get some meaningful information. Okay, so this talk, the objective, data is there, right? What are all the different ecosystems, right, around the data? Okay, so that we need to be aware of, whether it can be from the solution perspective or you as a developer, right, or as an architect. Okay, so try to understand the different ecosystems available. And the buzzword is the data scientist, right? Everyone started talking about data science, data scientist, right? So what is the role of the data scientist, and what is a data model, right? We'll try to understand some of those things. And the machine learning and deep learning, right? Again, people keep talking about it, right? So we'll try to understand what is machine learning and deep learning with respect to the data. Okay, so this is what I'll try to do. And right, so everything whatever you see now is considered as a data, right? Whether whatever I am talking now, the video that is being captured, right, and the tweets probably you are making now, right, about the session, whatever, everything is considered as a data. Okay, but the key challenge is what is the key, the information that we are going to derive out of it, the meaningful information, right? So that is the challenge. So the data, there is no limit to it. Every day we are keep generating the data. Okay, so the problem comes, right, how effectively I will make use of the data. Okay, so we'll take that as a problem statement, and we'll try to understand that how someone kind of should approach this. Okay, so everyone is having certain requirement. Okay, so probably this guy might be wondering that, okay, I have a huge set of data, right? I need to improve upon my business. Okay, so what should I do? Okay, so those are the questions he might be having it, and every one of us is having the same question, right? I'm having data, what I will do, how I will get a meaningful insight. Okay, right? So from the developer or as an organization perspective, how we generally approach. Okay, so as I mentioned that the tools are available. Every other organization is coming out with a tool, making our life little easy. But some of the things which the questions we have is, okay, how I'm going to collect the data, right? And how I'm going to store the data, that is also important. And in what way I will get a meaningful insight, the deep information from the data, that is very critical. And how I can take decision, that is the ultimate aim, right? With the data, what we will do, we like to take the decisions, right? And what would be the recommended approach. Okay, so the basic steps are very simple: prepare, store, and analyze. Okay, so whenever we talk from the data perspective, the very basic steps are prepare, store, and analyze. So what we mean by prepare? Getting access to the data, right? You might be generating the data live, okay, or you might be having the data stored somewhere. It could be either on premise within your enterprise, which is behind the firewall, or it could be in some other cloud providers. Okay, your application might be running on one particular cloud provider, and your data might be with some other cloud provider. Okay, so you need to kind of consider that how I will reach to the data. Okay, see, I have a small device, right, which I am planning to track my heartbeat. Okay, so this is one kind of data. If device works, let me see. Right, this is a device which is going to collect my heartbeat, and the next intention is generating data is fine. Okay, how we will make that available. Okay, so get yourself prepared for the data. It's a bottom line, and every other platform providers are giving you lots of tools. Okay, and if it is from IBM, you can probably search for Watson data platform. Okay, and I am sure Microsoft Azure, everyone might be having their own way of approaching this. Why? Because this is the basics, very important. You need to have access to the data, and storing the data also is very critical. Okay, and the question, I missed the T-shirt. Just I was about to ask this question to that previous speaker. In what format we need to have the data available to the tool, right? He showed the big nice visualization, right? The fat fish and all. It looks very attractive, right? Good. But in what way I will make my data available? I should have asked that. At least I could have got the T-shirt. Okay. So storing the data is very important. Okay. So you should know your data, right? And how that has to be stored. Right, so we are moving from the period where the SQL based databases to the NoSQL, right? SQL based database is a very strong consistency, right? Those are the days where strongly transaction oriented. I deposit 10,000 rupees in my bank account, and I expect that the 10,000 rupees has to be there, right? Whenever I do the ATM transaction, I should see that, okay, 10,000 is there. If all of a sudden if it comes 100 rupees or 1 lakh, whatever it is, right? So that is not very kind of consistent model, right? So during the transaction period, we are looking for a very strong consistency. So the SQL kind of databases were meeting those requirements. But now the data is getting generated very fast, right? The social data is there, Facebook is there, Twitter is there, this kind of streaming data, the IoT data, right? But I cannot expect that strong consistency, mainly because of the performance, right? Strong consistency, look for various aspects so that it will ensure that your data is there. But in the NoSQL model, the databases like Cloud and Mongo, right? They work on the weak consistency model, which means like the data that is getting generated. If I want to store that in the NoSQL databases, right? The data gets stored in the database, but the consistency is, the importance is given to kind of move as much as of data possible to the database, and later on they will try to sync up each other. Okay, that is the model they are working. What that means is, if I deposit 1,000 rupees and if I send the query back to the database saying that how much balance I have, that is a probability you will get 0. Okay, that is a probability you may get 1 lakh, whatever it is. Why? Because behind the screen, these databases, they work in a cluster model, and like when I deposit 1000 rupees, the 1000 rupees gets deposited in one particular node, right? But when I send a query saying that, okay, what is the balance, that query might go into a different node. So that node might be having value 0, the other node value might be having 1000, okay, right? Since everyone works in a cluster and master model, they will replicate each other. At one stage, it will become 1000 at all the nodes, okay? But that is a weak consistency model that is required for the kind of data that we are generating now, okay? So you take a call, right, in what kind of database you need. If you are good, if your resources are good with SQL, there is a option available to kind of migrate the data from NoSQL to SQL, okay. And if you are storing it in the SQL, there is an option to move the data from SQL to NoSQL, okay. So the flexibility is given now, okay. You have the choice of choosing the database, right. Later on, from when you get into the analytical requirement, you have the option and flexibility to kind of move the data here and there, okay. So all the vendors are providing it, okay. So whether it is IBM or Microsoft, everyone is kind of giving that option in terms of how you can kind of move around with the data, okay. Try to keep that in mind when you deal with the data. Yeah, so when to use SQL, when to use NoSQL, right. So what is the kind of open source database you guys are using or you're working with, exposed to? Postgres, SQL. How about any other things? MongoDB. Only these two? Okay. So obviously even I mostly depend on MongoDB and Cloudent. I just pull something, like there are many open source databases are available, okay. And this current generation and are basically in general the open source community is doing a great thing in terms of making the tools available for everyone to consume. So it's not that we need to depend on the big enterprises. Even the big enterprises are kind of contributing to the open source, right? So we should be aware of the resources available from the open source community, okay, right? So having understood that, how to pull the data, right, from what resource, okay, whether it is on-premise, cloud to cloud, CSV file, whatever it is, JSON file, whatever it is, right, and then how to store the data. Now the next immediate step is analyzing the data, okay. So that is where in the previous session we saw that Power BI, they showed a beautiful way of visualizing the information, okay. So visualizing the data is your basic step in terms of understanding the quality of the data, right. So you will understand, okay, this is the data I have and this is kind of the inference I'll be making out of it. So you will look for the plotting libraries to plot graphs. It could be a pie chart or whatever it is, right, the histograms and stuff like that, okay. That is a basic thing. The next level is the kind of statistical information, okay. So the statistical information deals with, okay, what is the average, right? If you are collecting the information about the participants over here, and if the organizers wants to understand what is the average age of the participants today, we get into the taking into the average. Then we get into a standard the distributions, right? How well the age is distributed, okay. So based on the requirement, okay, probably next year they want to target more developer community, they will try to understand, okay, this year this is the average age, this is the spread, okay. So if you want to deal or get that kind of information, you will get into the statistical mode, okay. So level 1 visualization, and then you need to get into the statistical mode. And the third level is you need to understand the pattern, right. So when you have the data gives some information to you, okay. It gives some level of pattern. For example, like, okay, the number of gender, if you want to take the number of the male and the female kind of a thing, right. And the people who have regularly kind of attending this conference, I'm just taking some kind of scenarios, but you try to map it out, okay. So you look out for that kind of a pattern. That is the next level of the approach to the data. That is very, very critical, and that is where the role of the data scientist or the business analyst, right, they have to, the domain experts, they have to play a very key role there, okay. So try to understand the pattern, and that will help you to create a model. We will see what the model is, right. But when you deal with the data, keep in mind that the patterns are important, and then You just say that, okay, I don't care much, I'll just give the data to the system, let the system kind of do whatever it wants. There also we are heading towards that, okay. So we are not taking the pain of anything, I'll just collect the data and leave it to the system, let the system decide whatever it needs to, okay. What happens when we get into that phase? Is it okay? Right? Say no, don't worry too much. Right? We are still safe. As of now, we and the systems are complementing each other. Okay. Tomorrow, that we will see. Okay. It may overtake or it may take all the decisions. Right? But that is where we are heading into, and we'll understand a little bit more about that. Okay. So these are the very basic steps. Everyone is dealing with data, right? So first step is preparing data. What that mean by preparing the data? I don't have t-shirts, but you try to kind of give your thing. What we mean by preparing the data? Ensuring the data is available for us. Okay, either you will generate the data or it will be available behind the firewall or whatever it is, right? You have ensuring that the data is available. Storing, you take a decision that, okay, I will store this data in this particular format so that I will kind of use it for my requirement. This decision, one is from the technology perspective, second is from your resource perspective also. If you are comfortable with SQL, continue with SQL, or if there is a mandate that you have to use NoSQL, use NoSQL, but there is an option to kind of move from NoSQL to SQL. Okay, so that still you can use SQL queries, right? And the third thing is analyze. Okay, so analyzing the data, what are the different things? Visualizing the data. Second, statistical information, get some statistical. Third, patterns. Okay, right. And the fourth one is leaving to the system to decide. Okay. Right, this is the basics, yes, clear. Now what is this? Who does what? So there is a business guy and data analyst is there, developer is there, data scientists are there, right? So who you are? Are you a business person or a developer or a data scientist? In what way you will categorize yourself? Okay, let me understand. So who you are now? You are a data scientist. Okay. Good. So are you doing the role of whatever I have mentioned over there, role of a data scientist? Yes? All? Yes. Understanding the business problem? Yes. Preparing the data for analytics? Estimating the quality of the data, modeling the data, statistical information. Okay. So how many of you agree that the data scientist has to do all this stuff? You are a data scientist? Yes, you will raise your hand. How about others? No? At least, so can I say that you are disagreeing to this?
Do all this and more actually.
Pardon? Plus?
Plus, there are other things to do.
So, okay. There are many other things to do. Okay. Right. All right. So, if you ask 10 people, you will get 10 correct answers. Okay. So, you take all the answers, right? But it depends. Okay. That depends on the complexity also, right? We may have to have the understanding of the business. That is very, very important. Okay, so you can't say that I am a data scientist, I don't know what is happening over there. But my point of view is the data scientist should focus more on the modeling the data, okay, pattern. But of course, he should have the, the other things, right, the business. What is the business problem he is trying to solve, right? What is the problem he is trying to solve? Okay, that is important. Okay, so that everyone should have. So this is kind of information I got it from Google, right? So they are saying that data scientist is surrounded by, how to infer, I don't know whether data scientist is programmer, statistician, business person or mathematician, or they are surrounded by these people, okay. But in an ecosystem, these are all the stuffs involved, okay. So the data scientist deals with the machine learning, right, software, has to develop program, he has to deal with the statistical information, right. So you as a data scientist, you are surrounded by all this stuff, okay. All right. Right, now we will step a little bit onto the machine learning. That is where I just want to kind of stress a little bit more, because we are seeing a lot of things, right? But how that is happening? If someone says that, no, that is my image in the video, but that is not my voice, how do you prove that? People are saying that, right? right? So that is where the machine learning comes into the picture. Okay, you show a video and they are saying that okay, I'm there, but that is not my voice. It's quite ridiculous. People talk all this stuff, but the machine learning is going to kind of help. The deep learning is going to help you to kind of get all the information provided. Okay, so when you deal with machine learning, data is there. Okay, you will kind of categorize the data, right? So you, as a data scientist, right, as a person dealing with data, or you are a developer, right, better have this understanding, like okay, I'm dealing with data, right? So how, in what way I will categorize this? Okay, supervised learning, unsupervised, semi-supervised, and reinforced. So supervised learning, it's a little bit straightforward. Okay, you are labeling something. Okay, saying that email is coming to your inbox, and you are saying that okay, these kind of emails are spam, right, and these kind of emails are okay. Okay, so when you label that, and then later on when you get another email, it's easy for you to kind of quickly say that okay, this is a spam mail, okay, or this is not a spam. Okay, so that is more of a supervised learning. We are coaching, isn't it? So if I teach coach a kid, like okay, this is ice cream, I given a bar ice cream, right? And then whenever I show another ice cream, orange or whatever it is, it should be able to tell that it is ice cream. Okay, it's a supervised learning. But I have never shown cone ice cream. If I show cone ice cream, what it will respond? Will it say an ice cream? Yes or no? Okay, right? So supervised learning is labeling something. This is what it is. This is what it is. Okay. So similarly, the machine learning also to the system, right? We are saying that this is what it is. This is what it is. Okay. This is cat. This is cat. This is dog. This is dog. Next time when you give a cat, you should be able to tell that that is cat. Okay. So that is supervised learning. Unsupervised learning, it's more of classification, grouping. Okay. That is also required. So the classification basically, simple example could be news.google.com. If you do, it will kind of cluster all the relevant information. Okay, what happened in the assembly, whoever talks about, whether it is NDTV, Republic TV, they will give all the people information they've clustered around. Okay, so that is the unsupervised learning model. Okay, classification is there. Semi-supervised, basically some you will label, for some you will not label. Okay, basically if you are identifying some culprits or anyone who has lawbreakers, okay, those kind of things, you can't label that okay, he is a thief, right? So basically like you need to have a semi model where you will have some labels and then leave it to the system to decide. And reinforced learning is something like it's a feedback system, ensuring that you are getting a best response. The simple example could be we playing chess with the system, right? The system learns from our move, right, so that it will kind of adjust accordingly. Okay, so it's basically a feedback model involved. Okay, so when you get into a machine learning, you will deal across all this stuff. When you try to solve some problem, you have to consider this, whether it falls under the supervised learning or it's an unsupervised learning, right? All those things. So a simple example of a supervised learning, how much training data. Okay, so I have not gone to the training part. I will respond to that time. Okay, so the supervised learning, the basic example is a simple thing, right? 500 square feet, Chennai, Tambaram, probably this is the amount, this much is cost, and 1000 square feet this much it cost, and 750 square feet how much it will cost, right? So that is a simple model, right? So you are giving some labels saying that okay, 500,000, 750, how much it will cost, right? Based on that, it's a linear regression model. Okay, so this is one example of a regression model under supervised learning. Okay, so when you deal with this kind of numbers, right? I have 500 umbrellas in my store. Now the monsoon is going to come. Last year I have sold say 400. This time I am expecting more monsoon, so how much umbrellas I have to keep in my store, right? So that will all fall under the regression modeling. Okay. So again in the supervised learning, you are coaching the system saying that okay, this is what it is, right? And you are going to say yes or no. It's a classification model. Okay. So the example I have taken is basically you are coaching the system saying that okay, These kind of things are no the breast cancer thing. Okay, so they will say that it is malignant or not. Another example could be, it is widely used in the insurance sector. The damaged cars photos they will take and they will kind of coach the system. No, the system will learn all the damaged cars and then they will show all the good looking cars. Okay, so then if you drive your car and then unfortunately met with some accident, and then if you want to claim that insurance, you just take a photo of your the car, send it to the insurance. They will have the system in place, then that will clearly tell that okay, it's a damaged car, and they will process the insurance. It's all done. Okay, so that falls under the classification model within the supervised learning. Why? Because supervised learning, you have to coach the system saying that this is car, good looking car, bad car, whatever it is, right? I've given an example, probably we can skip. We talked about the classification and the regression, and the unsupervised learning is grouping. Okay, if I group this, I consider this as a data, right? How many people are there, age group, gender, and your profession, like all those things, income probably, right? Then I can kind of group this, classify this group. Okay, how many of you are having diabetics or not? I'm just taking an example. Okay, right? So if I want to understand that, that is a kind of a grouping classification model. Okay. All right. So having understood that data is there and this is how I need to consider my data and to get some meaningful information, what is my next step, right? People are saying machine learning, what is my next step? Okay, so from the machine learning we are getting to the third category, right? Visualization part, it's very straightforward, right? Plotting, pie chart and all those things. Second, the statistical information, straightforward. You use the statistical library, you will get the mean, average, standard deviation, whatever it is. The third thing is the modeling the data, right? Understanding the pattern from the data. Okay, so how to model? There are many research work is happening in many academic institutes. Probably if you kill 1,000%, then you are considered as a doctor. Okay, then what is the definition for engineers? Okay, right? So we are also into the profession, right? And it's a very good profession. Okay, and so I would say that every engineer should try to kind of create some sort of a data model. Okay, so we should start kind of looking ourselves right into what is the kind of information I can get from this data, how I can kind of train. Today again in the newspaper it came that in the UK in one of the university they will kind of train the system, right? They will take multiple features of your face and then probably they will know like 60 years how you look like. Okay, in Photoshop all those things we do, but they are approaching that through the machine learning. Okay, so that the information what they are collecting is they will take the kind of different features of your face, the wrinkles, right, and stuff like that, and then kind of train the system, and so that they will easily tell me that okay, how I will look like probably 90 years old. Okay, so that the thought process has to come whatever you do specific to our requirement, right, our country. I read about another white paper from IIT Mumbai. They are doing the inflation that is happening. Okay, there are various factors involved. Monsoon is there, right? Demand supply is there, and then there is a kind of cost associated, right? And if you give subsidy for one thing, right, then the demand increases, right? The other gets affected. Okay, so they try to come out with a model to understand kind of the controlling the inflation. Okay, right? So think about many things, and then there are another article came in the newspaper last week. Why I keep referring the newspaper thing is like whenever you read something news, right, you as an engineer probably kind of start kind of train your mind in what way you will kind of insight you can get out of it. So there is an interesting news, like people from the urban areas, right, the number of diabetic people are less compared to the people from the rural areas. Okay, so the people are well informed in the urban. Okay, but this is reverse in the economically weaker states. Okay, economically improved states, urban population have a very good information. Economically weaker states, urban people are like probably whether not informed or they are not taking care of their thing, but their uptake rates are more. Okay. Now, using this we can build a model in a non-descriptive manner, right? We should be able to tell that, okay, you are from this place, this state, this city, right? We can add other features like your age, your lifestyle, right? And then I should be able to tell that, okay, whether you are diabetic or not. That's a non-intrusive way of finding some information, right? So, why I brought this example is, these are all the data, right? How we can model it, okay? So, how we can model? So, define, then get data, explore, choose techniques, get tools, model, deploy. Okay, defining is, this is what is defining, okay, whatever I mentioned. That the information is there, rural, urban, right? So, you just define, okay. And another example I quoted is, how we will look like after 20 years, right? Defining that. So, you are kind of extracting some information, right? Features of your face, right? Features of the, when I say feature here, in the example of urban, rural, diabetic, their age, their state, their city, their lifestyle, their work, right? You can add. The more the features, right, more the information you will get, okay. Now, this is the critical part, right? Using the tool is very easy. Microsoft will give, IBM will give, Azure, whatever, Amazon, everyone will give their tool. Using the things important, but when we solve our own problem, when we generate, like our own data, how we are looking into it, okay, defining, kind of in what way, like what is the kind of a problem I am going to solve and what are the information I am to take. Domain expert is must, right? When you are dealing with solving a problem, right, please consider having a domain expert. Without the domain expert, you cannot do anything. Domain expert is the one who will bring this kind of features. Okay, so machine learning, the first step is definition, define your data, extract the features, very, very critical. More the features, more, like you will get a more meaningful information. Less the feature, like little challenge, okay. Now, I've taught the kid ice cream, okay, choco bar, mango bar, orange bar, whatever it is, more coaching, okay. Now, if I come with the cone ice cream, what happens? May not be able to visualize that as an ice cream, right? So, now his question is, what is that training? How much training is required, okay? The system should be able to generalize. If the kid is able to tell that, okay, this is also an ice cream, then that model is good. So, the model which I have taken showing the different features of the ice cream, this is the choco bar, this is the mango bar, right? This is the, what is that, vanilla, strawberry, whatever, like that's more coaching, right? But it is not able to generalize the cone ice cream, okay. So, too much of data also is little dangerous, okay. Too less data also is dangerous, right? An optimum, okay. There again, the role of the data scientist comes into the picture. It's a trial and error. You will not get the accuracy in one shot, okay. So, he will kind of train the system, right, and find out. So, there is a 80-20 rule is there. If you have the data, probably you can consider say 60% of the data for your training, okay, and then 20% for your validation or testing, and then 20% for validation. If that is not working out good, change, right, and then see which is giving the correct accuracy, okay. So, if I start coaching the kid saying that, okay, this is the ice cream, this is the cone ice cream, right, and then probably different flavors, okay, then it should be able to generalize, right, and okay, this looks like an ice cream. If I give more features, like after some time you will see something started melting, that can be called as an ice cream. That is more kind of generalizing the information, so that the kid will be able to kind of come out with the right answer. So, that feature extraction is very, very critical, okay. So, definition, and there are any domain you take, okay, you can kind of if you want business more scenarios, I will show one more slide. I have not captured here, but any scenario you take, this is the first thing, definition is important, getting the feature information. Second thing is understanding the quality of the data and the relationship between the data, okay. So, here basically if I want to find something like see how long are the healthiness of a person, okay. And I can start with the classification saying that smokers, non-smokers, people who are maintaining diet and no, don't care about their diets, age less than 30, greater than 30, right. If I collect this data and I will plot it and I will see that okay, whether that is good enough, right, then I will think that okay, the classification of less than 30 and greater than 30 is not good enough. Let me see, I want to understand 30 to 40, 40 to 45, 45 to 50, like that I will try to improve. So that kind of an meaningful insight you will get when you start visualizing, plotting the data, okay. So the second step is you try to understand the quality of your data, okay. And the third step, right, it's basically the machine learning algorithms, okay, right. And here is where like we need to consider whether it is a regression problem, whether this is a supervised learning, right. And so from the machine learning perspective, I'm not covering that here, okay, the basics of machine learning. I'm just covering the approach from the data scientist perspective, okay. But you read about the machine learning, right, and they talk about they talk in terms of basically taking the input, right, and then kind of so some of the terminologies I'll just so let me see where I can start from the machine learning. Is there anything? Okay, right. So yeah, go ahead.
Yeah, one thing which there's a business problem.
Yeah.
When you use automation and use machine learning, that you see a business problem. Okay.
Yeah.
This should be classified as we solve through machine learning. This should be classified as solved through regular automation.
Yes.
What type of inputs or information will help you to classify that whether you should go for machine learning or automation?
Right. So the question is, I have the data, right? I have a business problem. Okay. What kind of like approach will help? Whether I will go for a machine learning, or I will able to kind of get a meaningful insight without using the machine learning, right? So now the machine learning, what it offers, I think that part I have missed to capture. Okay. So I think that is required here. So what the machine learning offers is, you have collected the data, right? You have kind of understood the quality of the data, right? The machine learning helps you to kind of generate information. What example I can take in this context? Okay, let me take a scenario. Okay, whether a person is under stress or not. Okay. I'm taking a scenario, probably may not be relevant to you, but try to correlate so that you will be able to so now as a musician, okay, I'll be playing some complex classical pieces, right, and I'll be playing a simple straightforward light music, okay, and a well professional playing and a person who has practiced nothing and he is playing on stage, right, but I need to understand whether whether how far he is stressed, okay. So the information I am having here is his basically the heartbeats, okay, right. Now do I need to use machine learning to understand this, whether this person is stressed or not, right? I have the data, right, I have the heartbeats, right, I have the time when it is the data is collected, right. Simply by plotting the the heartbeat, okay, may not be good enough. Probably I can get into the next step, right? Moving from plotting, I will get into the next step of doing some statistics. I will just take, okay, his average, the heart rate, okay, from say this particular period to this particular period, right? Let me see whether that is good enough. Okay, probably that may not be good enough, but I will understand that, okay, from 6 p.m. in the evening to 6:30 where he was playing the classical piece, right, his heartbeat was a little bit more pumped up, so he is little under stress. I will get that information. But now, whether the same person while playing another piece in a different concert, right, whether he will be stressed or not, right, for that we have to step into the machine learning. Why? Because with the current information, I may not be able to tell. So what I will do is, using the same data what I have collected from this particular concert, I will train the system saying that See, these are the different scenarios. This guy is stressed. These are the different scenarios. This guy is kind of little relaxed. Okay. Now I will classify this, saying that okay, he is stressed or he is relaxed. Okay. Now the same person, he is playing the music in a different concert. Now I will start generating the data. Now the data probably I will map it with the classification which I have done. Okay. Now that will tell that whether this guy is relaxed or stressed. Okay. So when you get into that mode, using this data, right, I am training something, and the next I want to kind of get some meaningful information with the data which I will be getting in future. You have to kind of model the data, and that is where the training is required. Is that clear?
Yeah. So does it involve that predictive?
Yes, you are stepping into the predictive mode, right? So the predictive mode falls under the category of the regression, right? And this yes or no falls into the category of the classification. Okay, so if you want to classify something, right, what is the probability that you will attend this conference next year, right? Machine learning model is required, right? So your behavior, your response in the social tweet, right? The way you are interacting, all those the features of the data, right, which I collect, and then I will model. Okay, and next year, probably the way like you are tweeting and other stuff using the data, I should be able to tell that whether you will be attending this conference or not. That is how we are getting into the machine learning model. Is that clear? Okay, you have the data, you derive some information out of it, either statistical or plotting. Okay, but when you step into the next level, what happens, right? You will know the predicting. Okay, predicting or classification. So you have to get into the machine learning model. Okay. Yeah. So the machine learning model, what it offers is basically from our end consumption perspective, it's all available as an algorithms. Okay. So there are various algorithms available. Google is coming out with an algorithm called TensorFlow. Okay. They have contributed that to the open source community. So now it is available as a open source algorithm, right? So TensorFlow is making our life very, very easy, right? So the machine learning itself has lots of properties, something like hyperparameters, entropies, okay, gradient descent. These are various terminologies you try to read about. Unfortunately, like I'm not covering that here. Okay, that is a kind of a black box for this particular session, right? But they are also making that as a black box, TensorFlow. Okay. So you should you will be consuming that entropy is nothing but like how you can cross entropy is nothing but how you can improve upon, okay, like your output. Okay, so gradient descent is nothing but from the current output I will give the feedback and then I will try to improve upon my response. Okay, so you have to make the API calls. Okay, so the libraries are available for us to kind of consume and then kind of prepare the model. Okay, so machine learning plays a big role over there, and it's all algorithms on paper starting from 1950s, right? The research paper, people have written it, n number of algorithms. So algorithms, there is no kind of limit to that. Right, so when you approach the solution, it's not that one algorithm is going to solve your problem. You have to kind of consider multiple algorithms. So there are different algorithms available. It's all probability, right? Distribution. Okay, one simple example just to give you an understanding of the algorithm. See, this naive Bayes algorithm is there. Okay, so what they will do is they will have, say, in a bucket, say 100 of red oranges, and then they will have in another bucket hundreds or 50 green oranges. Okay, and these two buckets will be here, right? 100 red oranges, 50 green oranges, and then you put white orange, say closer to this green bucket. Okay, now we want the system to predict, okay, what that white apple is. We know that it is a white, right? But how the system will try to interpret that is, since it is closer to the green bucket, right, it will take that value and then it will kind of normalize the values surrounding, right, and then it will take a probability value of what is the probability that it will be red, what is the probability it will be green, right. Then it will kind of come out with an response, the probability of this apple is probably red or green. So that is how the response will come. Is that clear? It will not clearly say that it is white apple. Okay, that algorithm definition, right, it will kind of give you the impression that I am confident 70% this is a green apple. Why? Because it is closer to the green bucket. Okay, right? So that is how the machine learning will try to interpret your data. Okay, it is not a very discrete in terms of saying that I am confident 100% this is orange, red orange or something like that. Okay, always it comes with the probabilistic. It's a probabilistic nature. So you as a consumer, you will take a call whether this is good enough for me to kind of move to the next level. If the system says that it is a green apple, you take a call that okay, I will take this as a green apple, then I will give feedback, then I will try to improve upon that till I get the white apple. Okay, so this is how the algorithms are available to us, right? And it's a careful choice of the algorithm also matters. So the the tools, right? The advantage here for us is we no need to kind of build something to kind of improve the efficiency like the cross entropy, right, or to kind of do the gradient descent, all the stuff. It's all available as a library for us to consume. Okay, so my general like input for you is start exploring TensorFlow. Okay, it's an open source library, and you can search in Google to kind of get the further information on that. All right. So the machine learning approach is this, right? You prepare the data, which means understand the features, right, and all the stuff. Probably we'll take a simple scenario, apple and an orange. So preparing the data, the apple is red in color. This is the shape, right? And it's a little shiny and all the stuff we can say that is a feature, preparing the data, right? And you train the system. So training the system saying that okay, don't take one apple, probably you take 10 different apples, right? And then you kind of train the system. So you can have 100 apples and you take 60 apples to train the system, okay? And then you use the 20 apples to kind of test whether that is coming out as an apple or not, right? Like that you improve upon that, okay, validate till you kind of get that closest answer saying that okay, this looks like an apple. Okay, so this is the model building. Okay, right? So as a data scientist, once we kind of dealing with the problem, right, as he kind of asked how I will decide that okay, it's machine learning required or not, right? Solving a problem 2 plus 4, machine learning is not required. What is the average age of this crowd? Machine learning is not required. Statistics is good enough, right? But whether someone will come next year, right? Probably yes, you have to use the machine learning. Okay, so that is a kind of like how many people will attend next year, you have to build the model. So for that you need to collect the data. Data is very important. You define the features of the data, right? It is all completely in your hand. Experts inputs are required. Okay, so this is how the machine learning is approached. Coming to the demo part, the challenge is just want to, the title given to me is plug and play, right? It's all 2 minutes noodles only these days we are looking out, right? I want the data to be kind of available, see something, right? But it's not working. I'll give it a try. So I have 3 electrodes connected, okay, and these electrodes are connected to this device. This is one startup in Bangalore, Lyfas, Lyfas. They are working on this. How many of you are startup here? Okay, good. So let me know if you need anything. I just kind of mentor the startups. Okay, post the session. So I'm working with this guy. So interestingly, like I saw another news today. In Germany, there are roughly around 2,300 varieties of bread. Okay, so now the one startup in Germany, he started making bread so that will be consumed in space. Okay, the bread will have the crumbs coming out, right? So he is applying the technology so that the bread will not yield out, the crumbs will not come out, so that in the space, that's a very dangerous one. It will get into the devices or eyes. Okay, so he is working on that, thinking that in future, right, going to space will become a common thing, right? So that he can sell the bread over there. Okay, it's a very interesting topic, but the point here is the startups thinking has to be different. Okay, and you have to startups are really good doing in India. Okay, so I strongly encourage the startups to kind of go forward, and tools are available, technologies are available, mentors are available. Finance, don't ask me, funding is a challenge. Okay, If that happens, then that is a different thing. That is a risk you have to face. But startups are really doing great work in India. I think that is where our innovation index has gone above to 60. Okay, soon I think we will improve upon that. So this device, right? So I'm connecting, and I'm switching it on. So this is an IoT device, right? So this and this through Bluetooth, okay. I want to share my mobile screen, and that is another, till yesterday evening it was working fine, okay. But now it is giving me all sort of challenge. But let me at least see, okay. So now what I'm doing is I'm trying to connect to this device through Bluetooth, okay. So I have connected, and I could see the data. Probably in case if you are able to see, some graphs are being plotted. It's basically multiple parameters of my heart rates, basically bits per minute, right? SpO2, pulse rate, and they are taking lots of the amplitude, the ramp amplitudes. Okay, lots of parameters they are taking, right? And now the next intention is I need to transfer this data to the cloud. Okay. Now I have already configured saying that push this data to the cloud, and let me see whether that data is coming to cloud. Okay, so the data is started coming to the cloud. Okay. So you will see this, I am clearing this debug window. Yeah, now the data is coming to the cloud, and at the same data I am visualizing it over here. My heart rate, it says 112. That shows I am little bit tensed, I am on stage, right? So probably right now it is 113, 112. But I am relaxed now, it should come down. Okay, the same, now the data is there in the cloud. Okay. Now the next step is I need to analyze this. Okay. And see my requirement right now, straightforward requirement is I will store this data in the cloud, right. So what I will do is I will go to the cloud thing. This is the Bluemix cloud platform, right. Every vendors have their own flavors. So here what I am doing is it's a Node-RED based. How many of you are aware of Node-RED? Okay, no need to code anything. Okay, so what I am just doing is I will take a database. So in this case I am storing this in a NoSQL cloud end. Okay, so I am just directing this data which is from the cloud to the cloud end database, and I will call the database name as Genesites probably. Yeah. SIGHTS, okay, SIGHTS, right. So let me call the database name as Genesites, and all I need to do is deploy. It is successfully deployed. I am clearing the screen just to make sure the data is flowing. I will go back to the cloud and database. I need to refresh this. Interestingly, you see the database Genesites, right, available over here. And you see the same data, BPM is 111, okay, at the time of, right. So this is the plug and play. These days, you don't worry about the end thing, okay, it's all, now it's like anyone can do it, right. Right, so it's a 5 minutes job, right. So easily the device is connected, data is published to the cloud, from the cloud it has gone to the database. The next thing is I need to visualize this data, okay. So what I will do is, this is another challenge I am having it. Let me see whether it works. So IBM has a tool called IBM Data Science Experience. So keeping in mind all this flow, right, what the data science is required, data science guy is required. Okay, so the Data Science Experience is another tool which will which supports the Apache Spark platform and the Python notebook, and we also support the TensorFlow libraries. Okay, so now the data is coming to the database, and so what I am doing to do is I will connect to this database. So what I will, let me check, I am just giving the database name as Genesites. What is the spelling I have used? GENI. Okay, so this is the Python notebook. Okay, for the machine learning, Python is the preferred language. Lots of libraries are available, and you no need to have the Python. So you can approach. This is a cloud way of approaching it. If you want to do a machine learning, you need to have a system with the GPU, general processor unit, a high computing thing, and then you need to install the Python libraries and all those stuff. But when it comes to cloud, that is the advantage you have. You no need to worry about all these things. You kind of start working or solving your, focus on your problem solving approach, right? And use the tools available in the cloud. So here it's I'm just setting the context, and then I'm giving the credentials of my the cloud and database, right? Now I'm in this cell, I'm just saying that load this data, okay? And it was working yesterday evening, and during the break I checked, it was giving some trouble. We'll see, it is taking time, it is loading the data. Hopefully if it comes. Just watch out for the star so that it is loading the data from there. Okay, 22 seconds it took. If there is no, okay, there's an error message. Okay, so I need to find this out, why this guy is giving this challenge. Okay, all right, but the intention here is I lost my other things also, the graphs which I would like to plot. Okay, so the intention here which I want to show is using this kind of a notebook, and so you will load the libraries like this. Okay, you import the math libraries. There is a Panda framework. Okay, so you as a developer or a data scientist, should have this awareness of what are the different frameworks available. Okay, and what libraries are available to use. Right, you can just import, and then you can, here it's a very statistical plot I have done. Just plot the histogram of the BPM. Okay. This is one of the older data, not the current data, right? It will plot it and give it to you like this, right? And right, you can kind of this is more of a visualization part. I'm not talking about the machine learning over here, okay, right? So now after doing this, my next step would be the machine learning, okay? So what it is, the same scenario I mentioned, right? Whether I'm stressed or not, when I go and speak in the different conclave or a session, right? When I build the model will tell that, okay, Rajesh is stressed or Rajesh is relaxed. Okay, that kind of an information it should give. Okay, so that is a next level model I will build. So to build that model, I need to have the corresponding machine learning libraries. So it's nothing but the library call. I will just show one notebook. This is just to demonstrate the plug and play capability. Okay, it's quite unfortunate I couldn't show the live thing, but the bottom line message which I would like to give is focus on the data definitions, right? Feature extraction. That's where you need to spend more time. Just to see a quick thing. So this is a sample data available, basically 0 to 9, right? Whether you can draw 0 or 1, or then the system will come back and say that, okay, that is 1 or 2. Okay, so here I will only point out the libraries. Okay, TensorFlow library I have used. Okay, see, right, it's a library call. I just want to show that, okay, gradient descent optimizer is there, and now these are the machine learning library calls. Okay, right, accuracy. See, the accuracy is just 20%, right? See, what that means is if I draw 1, there is a probability it may say that is 7. Okay, how to improve the efficiency? Let me see. I can at least show that. Training is very, very critical. Taking the amount of data for training is important. So keep that in mind, that ice cream I've told, right? How much data you are using to train. So here, let me give it a try whether I can improve the efficiency, which is 20% now. I will say that I will take I'll do more looping, okay, say 1000, and then I will run this. Yeah. One last try, then I will move on. It's extracting the data. This is a data set. I'm just importing the TensorFlow. This is a matrix. Behind the screen, it's a matrix. I think 28 by 28 pixel shape images are loaded, and softmax is another machine learning basically approach. You know, like since it's a system, we need to add some weights. Okay, so that is the things mentioned over there. And this is the cross entropy I'm doing, gradient descent to improve. Now, if this works, okay, I think it went fine. Okay, good. So now the accuracy, let me see. I'm going to run the model with more training data. Yeah, now it is, I don't know whether it's less. Okay, it has gone bad, 0.098 if I increase. Okay, so this is how it is basically, right? You have to know like in what way you will improve the accuracy depends on the training data. Accuracy here, it's a character recognition data. Okay, 0 to 9 images I have. If you draw 0, it should be able to tell 0. Now, if it is accuracy is so bad, if you draw 0, it may say that is an 8. Okay.
That accuracy is, how stressed are you?
The accuracy is how the model which you have created is accurate in terms of giving you the right response. So, what is the problem here? Problem statement here, I have 0 to 9 image and someone draws 0, the machine should be able to recognize that as a 0, right? Now, this model accuracy is 0.098, okay. So, what I am saying is if someone draws 0, there is a probability it may say whatever number it is, right. So, you as a data scientist, you know, like this is where you will play around, right, in what way you will consider the data, right, what is the training set required, okay. So, that is the activity the data scientist has to focus upon, okay, so primarily, and the tools are available and it is really plug and play, okay. I will take 10 more minutes, okay, or 5 more minutes. So, we have understood the flow like machine learning required, right, for doing some predictive modeling or some classification, okay. What is deep learning? What is your understanding about deep learning? Anyone?
Summation of series of logistic
series of logistic curve in a much simpler manner. It's basically giving an input, right, and then you are doing multiple computation to derive an output, okay. So, you are going deep, taking more features into consideration, okay. So, that is what is a deep learning. As I mentioned, if I talk, the system should be able to tell that, okay, this is Rajesh Jeyapaul, okay. For that, deep learning is required, right. Why? Because training that my voice, right, that lots of iterations or computations are required, okay. So, what is the basics of deep learning? Quickly I will tell, I will show a couple of demos, right, and then I can take questions. Okay, yeah. So, the deep learning, what a cat looks like, right, speech recognition, image search. This needs multiple layers of iteration to kind of derive the information. So, what that means, and this is applied to the text, the natural language also, right. If I give a newspaper, right, the system should be able to kind of go through that and then tell me the information, right, conveyed in that news clip, right. So, what is happening in the Tamil Nadu Assembly, if I ask, whatever you have seen and whatever you have read about, right, you should be able to tell. But when I give that piece of information to the system, the depth of the information the system will give will be more than what we could able to recollect and tell, right. So, how that is possible? It takes the character, right. For example, like sliding window protocol, we are all familiar, TCP/IP, we use that, right. So similarly, the machine learning, what it will do is you give thousands of characters, they define a sliding window saying that 4. What that means is they will take text of 4 words first. Okay, this is cat jumping above, whatever it is. They will take only those 4. They will slide through. They will build the context, right? And then they will try to kind of come out with a meaningful information. So is it possible for a system to kind of quickly compute and come back with that kind of an information? It's quite challenging, right? So unless you have a powerful computing mechanism, right? You lacks of huge amount of information is being fed to the system, but you don't have a computing capability, you will not be able to derive that information, right? So deep learning needs that kind of an infrastructure. So everyone is coming out with their own processors. How many of you are aware of NVIDIA? NVIDIA, right? So NVIDIA primarily focusing on the GPUs for the gaming industry. Okay, now it is their turn. They are right. They are getting much attention. Okay, the period of Intel CPUs kind of we are coming out of that. So what is the difference between CPU and GPU? Right, through this small video.
All right, I introduced to you Leonardo, and he's going to paint a picture for you guys in the way that a CPU might do it, as a series of discrete actions performed sequentially, one after the other. In 3, 2, 1. Let me speed it up.
Performance of CPU.
Ladies and gentlemen, Leonardo 2.0. When we hit this trigger on this thing, 2,100 gallons of air goes through these accumulators, out these valves, into all 1,100 of these tubes, into these tubes in which the bottom of is a paintball. Each of those paintballs will fly across 7 feet of space and in 80 milliseconds reach its target. Hopefully, when it's all said and done, it's going to paint the Mona Lisa.
GPU painting demonstration.
Yep.
In 10, 9,
8,
7, 6, 5, 4, 3, 2, 1.
Ladies and gentlemen, science class is now over. Thank you.
Okay, so we have seen the power of GPU, right? The parallel processing that happens, which is very much required to implement a deep learning, right? IBM has its own GPU, processor architecture. Google is having Tensor, right? And over the cloud you can consume the GPU processors. If you want to implement a deep learning model, right, you need to have the GPU processor. Okay, so this much of computing capacity is required, right? Then only you will get a meaningful information. We will see something in action. Okay, so what I have done is I will quickly show some demo. So basically natural language understanding, right? So if there is a good news clip you have, we can use it, but I just took tamilnaduassembly.gov.in. If you want to understand about, okay, just tell me a few things about Tamil Nadu Assembly, what you will say? This is general information about the assembly, right? Not what is happening there. Okay, see what is, when we ask what is the Tamil Nadu Assembly, what you will say? Chief Minister, so and so. Okay, St. George's Fort. Pardon? Opposition parties are there. Okay, right. So now the information what is mentioned in this website, right, I have given to the system. Okay, this is a natural language understanding. It's a deep learning model. Okay, so it comes out with various information. Okay, one is the sentiment it will give, right? When you write something of information, right, the sentiment, whether you are conveying positive message or negative message. Here it says negative, I'm not sure why. It's a government website. Okay, it's a very plain information, right? And information, the emotion part is there. Okay, joy factor is there, roughly around 50%. Okay, right, anger is expressed over there. And the keyword, right, it says that it is talking about the legislative. Pollachi Vijayaraman is there, ex-MLA pension is there, Honorable Chief Minister, Deputy Speaker, right? 15th Assembly, Vidyasagar Rao, acting governor, budget speech, right? So this is the kind of an information it will Dhanapal, right? And no, it will Palaniswamy. So see, right hand side if you will see the confidence factor. Okay, so the deep learning, whether it is deep learning or machine learning, they come out with their own confidence factor, right? I'm confident this information, this URL talks about this, my confidence factor is this. Okay, so this is a pre-trained model, right? It's a plug and play. These days you can consume it, right? It's all readily available as API. Okay, you come with your text, you come with your blog, right? And if you want to extract information, right, you can quickly do it. Simple use case scenario is these days these virtual agents are becoming popular, the chatbot, isn't it? So what is the weather in Chennai? Okay, if that is a conversation that comes in, if you want to extract the keyword saying that Chennai, okay, you can use this kind of natural language understanding that will extract the keyword, and then you can go ahead and use that with the weather API and get that information. Okay, so natural language understanding is another thing. Then something called tone analyzer. This is again used in the chatbots, right? So I'm saying that okay, I'm not happy with your service, right? The product what I bought yesterday is not working well. Okay, then the chatbot should be able to tell that I'm sorry, right? What is the issue? To say that I'm sorry, you need to understand the tone of my conversation, right? So the tone analyzer is the one which helps, right, to kind of get that information. So for example, I'm happy to be in Chennai delivering the session about, if I just say, right, if I tweet, okay, then we will analyze, we will give it to the system will analyze and say that okay, yeah, but what is the value? I couldn't see any value over there, or it says that okay, the joiners factor is there, okay, it is highlighting over there, but I couldn't see anything more. But this is generally the tone analyzer will try to kind of give you this information, right? Again, the emotions of the thing, whether you are expressing your anger or disgust, right? Whether you are open. So something similarly we have personality insights. Okay, so here also you give your own blog. Okay, it's like your jadagam. What kind of person you are, open, right? Or you are like whether risk taking person. Okay. Based on the simple blog or the article whatever you are writing, the system should be able to classify and tell, right? This is widely, it's again consumed in the industry. See, whenever the financial, the LIC agent or HDFC Life agent comes and talks to us, we generally tend to avoid them, right? Okay, I'm in busy meeting, come later, sometime later and that. So this is used to understand the personality of the investor, the personality of the executive, right? If both matches, they will kind of assign that particular financial executive to that particular advisor to that investor. Okay, so that the success rate is more when someone aligned with your frequency comes and talks to you. Okay, the probability is more you will listen to that person. Okay, this is again used in the matchmaking industry. I don't know whether that's the right approach or not. Okay, people are trying experimenting this. So if you are you have written a blog or your resumes, right? You can give it to the system. The system should be able to tell that what kind of person you are. Okay, so this is all the deep learning part. Okay, with the deep learning is involved to kind of see now I've taken the image of Dhoni. Okay, right? So now when you give it to the system, this is a classification done already, right? Behind the screen here, the IBM Watson, they have defined some pre-classification. When I give this photo, right? We can try with any other photo. It is trying to match that class. Medalist is a classification which already they have done. They have trained the system. Now using this photo, it says that 67% confident that okay, he is a medalist, he is a player, Olympian, right? Age, male or female. Okay. So the bottom line is what Watson has done is they have pre-trained, right, the photos. Features, they might have done lots of classification and then kind of they will map it whether with this photo and they will come back and say. This is the same approach whether it is Google or Microsoft. Everyone will have their own classification. The same image if I give to the Microsoft, right, they have their own classifications. Right, Microsoft gives whether the emotion part they are giving, right, neutral, sadness is 0.005. So this is how the system will respond back to you, right? So from the face, right, it is the Microsoft classification on the emotion is it's neutral. 97% I am confident that it is neutral. Okay, the message to take is see no glasses, right? Glasses, no glasses. So in their model, right, this is not available in the IBM Watson. Okay, in the Watson training model, they have not considered that particular feature of glasses. But if you see the Microsoft model, they have taken the glasses as a feature. So when they train the system, the deep learning, right, they will take that classification of the glasses. Now you give this image, they are saying that there is no glass, right? Similarly, you see from Google, right, they say that it's a person, football player, right, player, confidence level is 60, right, and they have some other interesting way of looking into the data. Okay, joy, anger, right, very unlikely. They're saying that very unlikely. Okay, right. So this is the kind of a classification, okay, happens behind the system. Okay, so the bottom line message is it's a plug and play for us. Tools are available, right? Make use of it, right? This is widely used, like in the healthcare. See, all these tools are available for what? It's all to solve the problem, right? To make our life better, isn't it? So insurance is one example I've given. In the healthcare, it is used basically the retina behind our eye. The diabetic people, the blood gets clotted over there, and getting that the red spots is really challenging, right? Doctors used to switch off all their lights, use their they kind of the infrared light to see whether there is a red spots behind the retina. Okay, but now you take a snap of your eye, the system will be able to tell that okay, the spots are here, and this is the likelihood that okay, right, advanced stage, whatever it is, right? The systems are trained, right, to solve a problem, something of this nature, and it is available for us to consume. Okay, so visual recognition, natural language understanding, tone analyzer, personality insights, right, and these all falls under the category of the deep learning. Okay, so the bottom line is it's all classification, models are created, right? We as a consumer, okay, to solve a business problem we have to take a call, right, whether we have to create our own model, right? When to create a model, we got into a good discussion, right? If I want to predict, if I want to classify, right, how many people will come next year, that's kind of a raw example I've taken, right? You do your own modeling, okay, but when you are implementing some solution, home automation, okay, people are directly consuming it. One guy, again a startup, right, how well you are maintaining your home. Okay, so if you are he is taking your conversation, right, if you are angry, most of the time he is giving that input to the insurance guy, saying that you have to charge more premium for him. Okay, right, so right, so that is the kind of a things, the tone analyzer is helping, right, and in the production line images are taken and that kind of help you to take the defective pieces, right, and so just think about in what way we can consume this model as it is. And also all the providers, right, Microsoft, IBM and Google, whoever it is, they are giving you the option to train these images. You can train your own photo, you give 50 images of your photo and then ask the system, it will tell that okay, this is so and so. Okay, so they are giving that kind of a flexibility also. All right, so it's a plug and play these days, all right, and understanding the basics, the bottom line, right, what is happening behind the screen, it's very, very important. And right, try to create some models. Google has plenty of information, GitHub has plenty of source codes, right, there is no excuse at all. Okay, you can't blame that okay, there is no documentation, this is not good, that is not good, it's all available. Okay, now it's a matter of how we are approaching it, right, how far we are spending time reading and implementing it. Okay, so that's the message I would like to convey, and probably if time permits I can take a couple of questions. Okay, all right, fine. Okay, so feel free to now reach out to me or Rajesh. So as I mentioned, I closely work with the startup communities. So if you need any help, let me know. Right, if you need a deeper sessions focused to your requirement, I'm available to do that. And if you want to validate your solutions, how to use, what to use, what is the fitment, right, I'm available to help you. Okay, all right. Thank you so much for patiently listening to this, whatever the so-called session. Okay, thank you. All the best to you. Thank you.
Stimulating speech and for sharing your knowledge with us. I would like to call up Mr. Sridharan to please present a small token of appreciation.